Let's start a new session with the MATLAB and Simulink. So if you remember, we have seen a new file and we saved it with the name first.slx. So here you will see the current folder, and in the current folder you will be also seeing which file we have recently saved. So this was the first file we created and saved it on the computer. Another important thing to remember is what is the directory path. So whenever you open up the MATLAB, it's very important to check the directory path, and then whatever files you have, that you can open it in the Simulink. So let's start a new session again, and for that you have to click on the Simulink button again. I'm showing you this. There is a Simulink button here, and it's also possible to type Simulink and run it. So another way is you can type Simulink. If you are good at writing the scripts and you are comfortable with the keyboard, it's also possible you can give a command Simulink and the Simulink will start. While the simulation is taking time to start, let me show you another important part is the help. So when you click on the help part, you will be able to see the overall MATLAB documentation, and this documentation is going to be of your all included toolboxes. So at the time of installation, whatever toolboxes you have added, all those toolboxes help will be located here. Now the Simulink is available. If you see here also we have a recent file, the first.slx, or you can also create a first blank model. So let's create a blank model, and now we are going to start learning about how we can actually add some of the higher order, or let's say some of the complex blocks, and how adding of this complex block will change the environment in the Simulink. So the other important thing to remember is the Simulink library browser, which is here. So when you click on the Simulink library browser, it will help you to view all the blocks together. So now I'm opening the Simulink library browser, and in the last session we have seen how to use some of the blocks where it's addition or multiplication and a display and some other blocks. So here when we have the Simulink library browser, let's know which are all these blocks available in the Simulink and what are the options as a modeling engineer with you, so that you can add mechanical and electrical blocks. So if you see here, there are so many blocks included, and when you click on this, they will get enlarged, and all those what are included in the selected block. For example, right now the continuous is selected, and all those continuous blocks, they are displayed over here. So whichever category you are going to select, for example, I'm going to select a powertrain block set and the drivetrain. So all those drivetrain block set will be appearing over here. So what you see as all these blocks are actually the larger level or high level model of automotive systems, such as planetary gear or torsional compliance or disc clutch and some other models. So this is about how you can get the higher level blocks, and you can take your time and have a go through this all block sets. And another important block set which we are going to focus on is going to be the Simscape. So what you see here is a Simscape, and in the Simscape you will have all electrical and mechanical physical blocks. So Simscape is nothing but the modeling of the physical systems, which means the actual systems in a Simulink environment. So if you click on the foundation library, you will get the driveline, and electrical and mechanical foundation libraries. So here are the foundation library of the Simscape. And if I click on, let's say, a mechanical, so in the mechanical system you will find the ideal force sensor, rotational motion sensor, ideal torque sensor, and there will be some sources. What is the meaning of sources? The sources are nothing but the actual creators of the force, right? So for example, you want to test a gear and you want to apply some angular velocity. So this is going to be the very right choice in your case, where you do not have any prime mover, or you want to virtually make any prime mover or a system where you want to represent this as a angular velocity source. So you have to take this block, add into your diagram, and just assign whatever angular velocity you want to give, and these values or these numbers will be converted into physical signals which are of actual angular velocity in the Simulink environment. So some blocks you are able to see as dark green, and let's say this one is some other green, and the remaining two are other green. If you see the bifurcation, their colors are different because they are going to be either angular or translation. So, or we can say the linear velocity or angular or rotational part. So all those rotational parts will be of this type of green color, and the remaining will be a little dark green, which represents the linear velocity, or we can say translation velocity. Now the same holds true for the electrical blocks. What you see here are the electrical blocks, and all these electrical blocks are actually represented by the blue colors. So whatever here you see are all blue colors. So Simscape has assigned blue color for electrical elements. Now something you will see over here is a rotational electromechanical converter, which is combination of electrical and mechanical system. So for example, the solenoid which we have seen earlier. So here you will have something with the red color as well, right? So in Simscape, the colors represents some different types of signal. So ideally for Simscape toolbox or Simscape block set, we have blue color for electrical and green for mechanical. And here you have everything for gas, hydraulic, magnetic, and maybe any physical systems where they are periodic operators or they are thermal elements. So here you have the thermal represented as the red one. So here whatever you see, all these are thermal elements, as you can see in the highlighted block, and they represent the red color. So red is for thermal. So whenever you open any diagram and you see some different types of colors, so which means there are some color notations assigned to them. So let's go back to our untitled model and let's have a look at help file, and let's try to run a pre-built MATLAB simulation. So what is a pre-built MATLAB simulation? So when we click on the help, we have to go to the main window for finding the help button. So on the MATLAB main window, so this is the main window where you have a command window, a workspace, and your current folder. So from that you will get the help. So from help, when you click on the help, and let's say you want to explore the Simulink and you are just interested in let's say some kind of a mechanical system which is a pump. So if you are interested in pump, when you type just pump over here, so this is a search toolbar, and whatever you type, all those results will come. Now the results may be of different type. So results may be the function, results may be the blocks, results may be some examples which are highlighted by this bulb. So wherever you find this bulb, they are actually the examples. So here we have few example: well with jet pump, or hydraulic motor driven by load sensing pump, right? So let's open any of the example and let's try to understand what this represent. So, and actually you have lot many examples which are built in by the Simulink itself, and here you can see a path where these examples are located at. So these examples are in your MATLAB installation directory, the example folder, then the Simscape fluids, then you have other subcategory of the folders. So you have this many different types of example. Ideally, the MATLAB has created for better understanding and the better usage. Each and every block or each and every element is associated with some or other type of an example which is built in. So let's open up this built-in example. So when we click on this, it's going to show us the help file for this and whatever is a system under consideration. So I'm not going to discuss the technical part of what's happening in this example, but let's focus on how we can get all these results, right? So we are interested in finding out what is all this model about and how we can actually run this built-in model. So once you have clicked on the well with jet pump, there is a key over here where you can open the model, right? So I recommend you to first read out whatever example you are going to try out. Just read out the technical explanation and try to understand how the simulation is going to be performed and what are the parameters those are built in and what is the situation that is created exactly. So when you click on the open model, and a model will open in another window. So this window will consist of this type of pump, and when we click on run, this is going to be a ready to run model, right? So it's possible that you can create your own model, but you can also view and run the built-in demo models, right? So this demo model is included with some green part, which is a velocity source. And if you remember, just we have seen this ideal angular velocity source, right? So this is going to provide an ideal source of velocity. And what is the velocity which we are giving? This is a constant number, and this constant amount of velocity, which is again converted into from RPM to radian per second from this equation, that is given to this velocity source, and that is given to a centrifugal pump. So the centrifugal pump is going to actually run some of the mechanical system where you have some tank over here, and there is a pipe, 1, 2 and 3 pipe, and here you have a jet pump, and there are water properties also assigned over here, and here you have another pipe. So once you run this simulation, you can observe the results over here in this scope window, right? So what are the all things which are plotted? They are Q2, Q1 and QT. So Q2 and QT, they are going to be plotted together in the same graph, and there will be another graph for Q1. So if I hit on the run, I need not to configure anything, or I need not to change anything, just to get the same result which is discussed in the help file. So right now our model is getting compiled, and if you have any errors, if you get any sort of parameters you have changed, it will not allow you to run unless and until your model is error free. So that is called the compilation. So compilation is nothing but checking for errors. So here your results are available, and whatever are the values from 0 to 10 seconds in this result, they are plotted in this scope. So what are the Q values? Here you can see. So this is the flow rate represented as Q, and they are this is going to be the flow rate primary, and this flow rate secondary, and the flow rate of the tank. So these are the flow rates which are plotted, and here you can see from 0 to 10 seconds which was our stop time of the simulation, these results are plotted. Now if you give some different angular velocity, instead of an 1800 rpm, if you give some 1000 rpm and remaining parameters are all same, you will get maybe a different flow rate, right? And if you may change the pump related configuration, or maybe the tank related configuration, or pipe and the valve related configuration, then all those change configurations will result into the changed output. So here are the results, and here there is one more feature of the Simulink, that you can run your simulation from the results window itself, right? So this is going to be the case where you press the green button, which is again same as this green button, and you can run from either of this window, and the simulation results will be plotted here. Now when you see this, you will actually realize that this model is having some text information as well, right? So let me zoom into this model. How you can zoom in? It's very simple. You can just scroll down or scroll up, or you just use the scroll button to get zoom in and zoom out. So what you see here is the help file, or we can say some standard Simulink template file, right? So here you will have a plot flow rate through the jet pump. You can also explore the simulation result using Simscape Result Explorer, and you can also learn more about this example, which is nothing but the same file which is we referred as a help file, which is this help file. So which will open up this one. So here we have the help related things well documented, and if you remember, all these things are related to the templates, right? So when you create your models using template, this block or this minimum things will be there in your model file. So I hope you now get the idea about how to run a demo. So running a demo will actually help you to learn yourself about how we can do the simulation and how to visualize the results. Now few more things about result. Let me explain you some results in a very brief. So what you see here is the result configurations, right? So whatever you have here are the main buttons in which you can see the result. So in the first plot here we have a 2 graph. So this 2 graph, as I am highlighting here, are nothing but flow rate secondary and the flow rate of the tank. So let's see what is the difference between these two. What is the difference between the flow rate of that secondary and the tank? So if I want to zoom in, I am required to use this part, and this is going to be the zoom option. So let me use the zoom option, which is horizontal zoom, vertical zoom, which is called zoom X and zoom Y, or we can use a simple zoom in by selecting this plot, right? So I'm making a square part, and I just want to understand what is happening in this duration of time. So now I see almost yellow and pink line to be exactly overlapping each other. So let's understand, are they exactly overlapping, or are there any other difference as well? So if we want to do that, we can do that by using the zoom, which is zoom on one axis and zoom on other axis as well. So I think if we zoom on a little bit, where we have now the second or now the time axis, which is very near, right? If you see this time difference or time represented by 1 unit, which is 1.776832 second and 1.776832 seconds. So this is going to be a very little time, and there is almost no difference, right? So they are exactly overlapping each other, and you can say the value of the primary flow rate is around 104.7, right? So this is about how to visualize the results, and there are other possibilities as well, where you can use the markers and if you click on this, the cursor measurement will appear. So what is a cursor measurement? So the cursor measurement window will appear on the right side, and it will give us the idea about what is happening. So if you are able to read what is happening, see there are two cursor. One is the first one, or one is a I will say the scale number 1 or the point number 1 of interest, and other is point number 2 of interest. So what is happening between point 1 and point 2, that is explained here. So what is the time change? And it is approximately 1.77 second, and these values are also nearly same with the yellow trace selected, right? And whatever you see is a delta, and whatever you see is a time change and a value change. So how much is the value changing for this yellow? That is 196.425 GPM per KS. So that's something with per 1000 of seconds, right? So this is about how you can use the trace, how you can use the cursor. Now if I deselect this, and it's up to me that to what point we need to use the cursors, right? And at any point of time you want to go back to the fundamental view where you have all the 0 to 10 second. What you have to do is use this part or use this button to just select how you can come back to the main picture, right? So here is how we have come to the main picture, and I need to deselect the zoom. Right now if you see, I have already selected the zoom, and the zoom part is showing me the dark. I need to just deselect it, so now it's not dark, and now I can move my cursor 1 and 2. So can you observe the changes in cursor 1 and 2, and whatever is the delta t and whatever is the delta y, right? So let's say in delta t is 5.4 seconds. So in the 5.4 seconds you have a delta y change of around 1. So this is what you can use the cursor and what is happening at a different time. Now there are configuration parameters as well, right? So let me remove the cursor first. So if I want to remove the cursor, I need to press this again so that the cursors will remove. So now the cursors are not present, and now I'm going to start with the configuration properties, which is this part. So in the configuration property here, in this window you can see the number of input ports. So here are the number of input ports. You can give a sample time as well here, and there are some other parameters, and you can actually choose the layout of the plot as well, right? So here you can decide how is going to be the layout. So this is a layout option, and where you can choose the multiple things: time span, the display, the limits, and whether you want a data logging or not, and what if you want to log the data to the workspace, which we'll see later, you can make it enabled from here. Now a very fundamental thing to be done is, let's see here the values are from 104 to 105 for primary flow rate, right? So you should not get it from 0 to let's say 500. So if you get a plot from y values from 0 to 500, it's not going to make sense, right? So all those scales are going to be selected by default. If not, you can change it from here. You can change it from all those axis scaling from here, and what is going to be the axis values from here as well, right? So you can adjust the minimum and maximum y limits, and your time limit can be again changed from here, which will also affect the similar time changes. So this is about the configuration properties, and most of the time if you do the auto scale, it is going to be get adjusted properly. And if you want to get display, you can click on the show legend, right? So if I remove this, it was already there, right? So if I remove this and OK, I'm not going to get what are the signals, what is represented by this yellow line and pink line. So for that, again, I'm going to click on the configuration, time, display and show legend. So if I select the show legend here, the show legend part is going to give me some idea about what are the signals. So if I enable this and press OK, now we have the legend of the plot. What is the actual signal that will be given? So with this, you have the basic understanding of the visualization or how to see the results, and probably there are so many other options where you can select about taking a snapshot. Maybe you can freeze the screen. You can actually whatever are all these options, they are listed here as well, and you can actually make copy to clipboard as well, right? So once it is copied to clipboard, you can easily paste it anywhere, and you can take a print of this file as well, right? So if we do the copy to clipboard, right, now it's copied in the clipboard, and if I just want to paste it in a paint, so this is going to be the output case, right? So if I just now press Ctrl V, we are going to get the plot like this, right? So copy to clipboard option is a better option when you are representing or when you are showing the result as a part of the report. So maybe if you can choose a print where it is going to be exactly the black background, but normally for a proper technical documentation, it's always recommended that you avoid the black background, and for this it's going to be the better option where you have copy to clipboard. Now when you copy to clipboard, the legends and everything will also be included here, right? So this is going to be the result post processing, or maybe the technical reporting part of it. So coming back to the results, let me close this window. Now let's say, for example, you updated something with the velocity source. Instead of an 1800 rpm, you change it to some other value and you will have some other results. So in order to remember or compare with the previous results, you may use the copy to clipboard button. So this is about how you can open up the help file, and you will not be able to actually make any changes to the default files, because they will be again affected, and so that you will not be able to reproduce the very results which are there or which files are generated by the MATLAB engineers. So coming back to the help or documentation part is very strong, and here you can see many different things related to, let's say, instead of an example, we want to have some help related to this part, right? So variable displacement pump. So we want to know how MATLAB can help us modeling this. So if I click on this, it's going to show me that what is the block available with the MATLAB, right? So if I show you, this is going to be the library, and pumps and motor, we already have a typical block which will look like this, and it is nothing but a variable displacement pump. Now how does the variable displacement pump works? It's all related curves, P and T and other related diagrams, they are available over here. With this window, you can actually press the control and scroll up, and you will be able to see the help with a bigger font. So what is this block about? What does this block help you to model? What are the conditions taken care of? What are the equations implemented? And what are other related things? So are there any saturation effect? Are there any leakage flow rate considerations? And everything about that model. So if you want to understand what are the inputs, what are the outputs, which are the ports, what are the parameters you have to configure, everything is listed over here. Now another important part, if you want to use some of the related parameters, right? Or let's say you are interested in something else which is nearly similar to this, then you have see also part, right? So when you click on the see also, you will be able to understand what are the other options related to this. So you have a fixed displacement pump TL, variable displacement motor available, and it is going to be look like this, and it is also similar in a way, right? So this is about the help. Now how to scroll through or how to browse through the help is also very important. What you see over here in the top left corner is how you can go through the help, and if I click on the back button like this, I am going to go to the previous page which I explored. So let me go back again, and here we are back at the pump page. So these are the results. So the results of the pump, and there are so many other things where you have an example along with the help topics, analyze and select the features of pump diagnostic, and you have a closed loop actuator, and where you can see there are actually many results coming up, right? So there are total 252 search results within the MATLAB related to keyword pump. So I think you will be now more clear about what kind of help or what kind of label Simulink offers in order to do a simulation with a pump. So let's go back to this, and here you are back at your main Simulink page, and what you see here is Simulink toolboxes. Again, they are in the alphabetical order. So whatever are the toolboxes related to that, you can get the idea, right? So here, let's say if we want to go to Simscape Electrical. So in the Simscape Electrical, you can start through the applications, maybe electrical block and the control and specialized power systems as well. So if we go back and browse through all these toolboxes, and let's say we have a Simscape, and in the Simscape also you have physical modeling, and how the physical modeling is taken care of, and here you will be able to see the mechanical models, right? Here you will be able to see the hydraulic, thermal models, and other related models. So if you click on the mechanical models, you will be having again a classification. Now this is same as if you are browsing your folder in your Windows environment. So you will see all the folders similarly situated like this, right? So let's say we go to the rotational elements, and we have all these things, which is let's say we are interested in rotational damper. Then if you click on the rotational damper, it is going to open up that library block. So this is going to be how a rotational damper will look like. And if you see the theory, what is the equation behind the damper and how it is implemented, that is given over here. So this is about the damper. And if we go back, and let's say if you take a rotational spring, you have something related to spring, and maybe you have some other blocks as well. So let's go back and let's understand some of the mechanical systems related help. So here we have a mechanical system, and what you see as all the block is they are simple mechanical systems, the linkage system with a translation frictional mechanical system with the translational hard stop, and many other featured examples. So here are the featured examples which are going to use all those blocks which are dark green, which are going to have a linear motion, and the another color of green which is light green, and you will see the rotational motion. And I think now it's a good time for you to open some of the model and try to understand how the MATLAB is going to simulate it. Now coming back to the MATLAB, here let's say this is the first file which we have created, and I can open up this file. And so this model was 12.3t, right? And where t is represented by this ramp input, and this is our commented out block, right? So we ran this situation and 12.3 multiplied with the 10 at the end of the simulation, which will give us the display of 12.3, and what we'll get in the scope is going to be the continuous increasing value starting from 12.3 to 10 times of that. So this is our first model which we created, and now you can undergo the very fundamental exercises where you implement your own equations and test them in the Simulink environment. Thank you.